In today's world, the effects of climate change continue to increase with the use of fossil fuels and other heavy carbon-emitting practices. We should all be concerned about the quality of the air we breathe outdoors. But what about the quality of the air indoors, within places of business, schools, and homes? As excessive levels of CO2 escape into the air, interior ventilation systems within homes and places of business become less effective as harmful carbon levels begin to rise. The EPA reports that billions of dollars are lost each year as a result of poor indoor air quality through reduced productivity, absenteeism, and healthcare costs, since we spend 90% of our time indoors.
In certain environments, localized CO2 is higher. So when we're talking about urban environments or any area that has higher levels of emissions, we're talking about a localized CO2 problem. So if there is a city with a CO2 dome over it, it means that the ambient outside level of CO2 is higher. In those environments, CO2 needs to be treated as a localized contaminant. So when you are talking about indoor air, not only in some areas is the baseline higher for the CO2, but also humans produce CO2. So if you have a building that is highly occupied, that could be a school, that could be a hospital, it could be an office space, then you're dealing with needing your infrastructure to address your CO2 problem.
The move to a lower emission future requires implementing solutions within the highest emitting sectors of the economy. By utilizing a building's ventilation system to capture and sequester carbon from the air, we can offset the building's annual emissions, improve the health of employees, and increase productivity.
The state of the art for what buildings are doing to deal with indoor air quality is to overventilate. In fact, you have a number of governing bodies that buildings look to that say dilution is the solution, which means overventilate your building to get rid of and expel all of the indoor air pollutants. While that may be a solution, that hikes up the energy bill for building owners. So they're left with spending more money than they should be. The downside of overventilating a building is it puts a strain on the grid for how much energy that you're using. Your ventilation system sometimes can account for as much as 40% of your total building energy spend. And when you're in an area where your grid is still on coal or natural gas, we're also talking the CO2 equivalent of coal or natural gas needs to be burned for you to use your building ventilation system.
Carbon dioxide is a long recognized air contaminant where if it rises to certain levels, it can cause a lot of health effects for people and cognitive effects as well. And we've seen over the last several decades issues with how people function, with how they feel as a result of rising carbon dioxide levels. It happens in schools too. Very often schools are built to the lowest bid, so it may not have the best ventilation system to begin with. You'll often see students and staff sleepy, not performing well, test scores go down. As a result of that poor ventilation, you see people with more respiratory complaints. I recognize, evaluate, and control workplace hazards, and most of them in my profession are airborne hazards.
Carbon Reform's mission is to increase the well-being of building occupants. Carbon Reform offers an affordable solution that retrofits into commercial buildings' existing HVAC system. With the carbon capsule, building owners can reduce energy costs, protect the health of employees, and support overall sustainability goals.
The device itself captures CO2, it filters particulate matter, there is VOC mitigation, volatile organic compounds, and then there is also UV light for disinfection. So we're addressing viruses, common contaminants, as well as carbon dioxide. So with the CO2, we're directly removing CO2 from the return air stream of a building. So what we're trying to do is clean the return air so that it can be safely recirculated inside the building. And then you have energy savings from having to bring in less outside air.
Carbon reform operates on a three-phase business model. And what I mean by that is the first interaction we have with the customer is phase one, which is our baseline indoor air quality and energy savings assessment. Once we identify the building with our customer, our engineers go in to deploy indoor air quality sensors so that we're able to monitor what's in the building over a period of time. We're also doing energy savings assessments. So based on the proprietary models that we've developed in-house, we can determine how much energy per square foot you're going to save by installing our device. Phase two is the actual deployment of the carbon capsule. It's a retrofit technology that goes into the building's ventilation system. And once we do that, phase three is the monitoring and the maintenance.
For the past 3 years, as a result of the pandemic, as an industrial hygienist, I've been vetting technologies across the board that make an impact on indoor air quality. Carbon reform with its carbon capsule rose to the top in those technologies because of its capabilities of addressing many aspects of indoor air quality, as well as impacting climate change adaptations.
Carbon reform is truly democratizing access to carbon capture technology. When we say that, we fully embody that. And what that means is we want carbon capture to truly impact the communities and the buildings that need it the most.
If we can not only do carbon capture on a large scale, but also impact individual people's lives while we're doing it, I think that's a really nice combination for how to address this at all.